Now let's continue with the static libraries. The static libraries, what are libraries and what are they used for? So first of all, what is a library? A library is a file that contains several object files that can be used as a single entity in a linking phase of a program. But first, what is an object file? An object file is the output from the compilation phase. It's mostly a machine code, but has infos that allows a linker to see what symbols are in it, and as well as the name, for examples of functions, global variables names, all these things, and some informations for the linker in order for him to do its work. So when you have a very big program, you don't want to always compile the whole code each time you make some little changes in your code. Let's say, for example, you have thousands of files everywhere. What happens if you make a little change and you have to compile the whole code again? It is not very practical. This is why we come with the idea of libraries. So we have two kind of libraries. We have static libraries and we have shared library. But for this session, we're going to focus on static libraries. Let's start with an example of code. So let's say we have kind of like three functions. Um, we're going to define three functions, and each of these function, we're going to add their prototype inside our main.h files as usual. Okay, let's add a file. I'm going to call the first function add a number. .c. This function takes up two numbers and it will return the sum in A and in B. Then return the sum A plus B. Great. And let's create another function called multiply, or let's say print hello world. This function does not return any value and doesn't receive parameters. We're going to say hello world. Then I'm going to include the stdio library in this file because we're using the printf function. Now let's add the prototypes in our main file, main.h file. And let's add the prototype for the add number. Great. So now we can include the header file in our main.c file, and we can now use these functions since the compilers now knows about their prototypes. I'm going to use the hello world function. Great. If you try to compile this code, you'd have to provide the files containing the definitions of each of these functions. For example, we're using the print hello world. So when compiling, you have to specify the print hello world, then the name of the executable, the name of your main file, and the output file name. So this is the standard way we're used to. Let's look at what this program does. And here it displays hello world. But now let's use add um, declare a variable called sum, and the sum will receive the sum of 10 and 33. Then we are going to display the sum. I'm going to include the stdio library because we're using the printf function. And let's execute this file again. Since we've added the add number function, we'd also have to specify the name of the file that contained its definition. So we're going to add the file add number.c in order to compile this program. And what happens? Let's execute, and you see hello world, and here is displayed 43 as expected. But now let's say you have thousands of files or millions of files, not just print hello world and add numbers. It's not very practical, and you don't always you don't want to repeat to compile your whole code every time or each time you make some little changes in your program. So we're going to create a library for that. In order to create a library, the first step is to create object files. So we're going to tell the GCC compiler we want to create object files from the print hello world and the add number.c file. And here we have the object files, the add number.o and the print hello world.o. These object files are just like contains instructions, understandable for your for the computer by the computer. So when you're creating an executable file during the linking phase, these object files will be copied around in your executable file to create the final program. So now we're going to create a library from these object files. So we can only use the name of the library when we're using those functions. In order to create a library, we have to use the R command. This will create an archive file. A library is an archive file that contains objects, and the object files contain the function's name and the global variable's name and so on. For the R commands, we specify these two options, the R option and the C option. The R options tell the IR command that if there is a change in one of those functions, we only want to replace the symbols or the object file in the archive if it already exists. And the C options tell the AR command that we want to create a lib file if it doesn't exist. So, and our library name will be something like lib. Always prefix the name of your library by lib, then the name you want to give yourself. For example, cool. Then the extension of the library will be A. Then after that, we have to specify the object files we want to include inside that library. The add number and the print hello world are the object files we want to add in our cool library. Great. So we now have the libcool library. Next, we can compile our main our programs with the library instead of using the files containing the definitions of these functions. So even if we have thousands of files, we only have to specify the name of the library and the compiler will take care of the rest. So in order to compile with the library, we use the GCC command, then the L option. The L option tells the compiler we want it to look for libraries. We want to add a custom folder for lookup. So it will look at the libraries we're going to specify. For now, we are in the current working directory. We have our libcool, our cool library in the current working directory. So a dot, then space, then the name of the library. The library name is cool, but here we have to prefix it with an L. If you notice is that what you can notice here is that the lib, we do not have the prefix lib here, even though the name of the library file is libcool.a. So we have to replace the lib with L. Then the extension, we don't have to specify the extension. Next, we pass in the name of our main file, main.c, and the name of the executable file after the O option. And let's compile. So what happens here? It's a undefined reference to print hello world and define reference to add numbers. So this is a bug. Let's say how to solve this issue. So what we're going to do, I'm going to change the position of the executable file name. And now the code compile. There is a reason for that, but I think we had to read in the docs, but the name of the libraries should come after the name of your C files, because the compiler, the linker read from the left to the right, but would not go back on the previous files to, but for now, I would invite you to look into the doc for more detail. What you see here is that we don't have to specify the name of the files that contain the definitions of our print hello world and the add number function. We only specify a single file name, the library file name. Let's see if the program executes. Yes, it does execute. So we have two ways of compiling the code, either by specifying the names of all the C files that contain the definitions of different functions, or create a library, then compile the code with that library, which is much more easier. So I'm going to repeat it again. We have the main.c file, then the different functions file, the different functions .c files, then the name of the output file, main. Uh, I think it is that hello world. There is a typo here. Okay. So we see that this one compiles, but we can also use our library to do the same because the library contains the object files of these two functions. So we tell the compiler we want you to look in the current directory for libraries. Then we specify the name of the library. Our library name is cool. Then the output file name. Uh, the O option, yeah, the L option. I forgot the dash. Okay, it does compile. So you see this and that there is a big difference because if you have thousands and thousands of files, you just compile a library, a single library. You create a single library, then every time you want to compile your code with one of those uh, functions, you don't have to specify or to think about the names of their files. Great. If you notice something about a printf function, let's see what happens here. I'm going to change a bit this code. And I'm going to say print hello world. And when you are trying to compile this code, you only say GCC, then the name of the main file, then you specify the name of the output file. I guess you've already noticed that we are not specifying something like printf.c or we're not specifying any files for the printf function. For the other function, for our custom function, for the add number print hello world, we had to specify um, the .c files, but for the printf function, we're not doing that. Why? Because the GCC compiler um, look by default some directories, and inside those directories we have the stdio standard library or the lib files that contain the objects files of the printf functions. So if we add our own functions, we had to specify manually the directories where the compiler can find our custom library. But for the printf function or for the standard libraries functions, we don't have to because the compiler looks by default to certain directories on your system, and those directories contains your standard libraries. So this is why we can compile the code without specifying something like print.c because no such file exists on our system. Only libraries exist for the printf functions. And if we run the code, it will display something. Hello world. Thank you guys. This is all for the static libraries. We also have things like the shared libraries, but this session is not focused on shared libraries. Maybe we might be looking in that for future sessions. All you have to understand is that we can combine the object files of different functions. If you have thousands of functions, you can create a single library file, then compile your code with this library file every time you need some of the functions that are included in that library. Thank you. Now the next part will be on dynamic memory allocation.